Hello and welcome to today's lecture on telecommunication. This is the part 2 of this lecture. So last time we looked into some telecommunication technology, network technology, including transmission channels, some application technology, and of course like communication technology that is more geared to voice. And we looked into the trends in telecommunication industry, business applications, some network devices, switch, bridge, router, firewall, and also for security we looked into this was the firewall and also a certain encryption and an encryption based system that was VPN. So after VPN, today we start with network server configuration. So over here we have a server based network. This is also like another term for this is a another term for this is client server network. Compared to this, on the right side we have a P2P network. So this one is a client server network. So that is what we have on this left side. So there is a server, right, which dictates a lot of things. For instance, who can access the server controls. So you put in a username and password, server checks all these different information and based on that it will give you certain access. Compared to in a P2P network, it is all the same. Not all the same. It means everybody has the same power. So everybody has the same or similar resource, and like you cannot just block one other person as easily, or one or more person. If you have used a torrent network, right, often for free and open source software distribution to reduce the software distribution distribution cost, torrent networks are used. Torrent network. So this is an example. So there is a central server, but central server is just coordinates where some of the resources are, and all the different resources, for instance the files are available through this server. So if you are this one and you want a file that is available in the torrent network, if this individual user says, oh, I don't want to serve you, or goes offline, and then you can still access them from here. So everybody has a so this is P2P. So earlier we talked about P2P, and this one was this is more traditional, like so this is the course website. Let's say institute website, any website, often it is a client server. So over here everybody is a server, everybody is a client, and over here we have some certain client, certain server. So over here we see a telecommunication network data sent, how data is sent. So over here this is satellite. So if your phone, right, so GPRS 2G 3G, so it goes to a BTS tower, then it can go, like assuming you are routing it to a satellite transmission through one of these satellite dish, it sends to a satellite, and the satellite, this satellite sits on top of the world, on top of the earth, and then acts as a reflector, right? So when what it does is essentially reflects this message. Well, it's more than reflector. Sometimes it does processing too. At a basic form, it does reflection, and then essentially it captures the data and repeats the data over here, and then it can come into, so it can come into this other server, right? All right, so the satellite, so this is one easy way. So again, the satellite, you can think of an easy way to relay your message at the distant locations, because within the earth, like let's do, like, if you consider the earth as a circle, right, so we can have a satellite anywhere in the earth, and like, so we can have a satellite over here, that's over here, and once we have a satellite like this, so we can send this data, right, like from over here we can send it a data, and then of course it can process and it can still send back this data anywhere, wherever there is. So of course over here it cannot, but over here it can, or if there is a second satellite it can go certain ways, multiple satellite networks, right? So if there is a certain satellite, it can go give it to that other network and so on. So it's similar to BTS. BTS provides, so if there is a BTS over here, BTS cannot provide a long range solution. So over here, if we have a BTS, if you could see this BTS, like again the range is very low. Over here, if you have another BTS, it cannot, like so whenever it starts sending data out, right, so you can see, like the earth, because the line of sight, there is no line of sight, it cannot provide data. It can provide data up to a very limited range, the BTSs. So that is another that is the one of the reasons that we need a satellite. Again, so this is a telecommunication channel which is satellite. All right, telecommunication media, we talked about telecommunication channel, we talked about, this is the media as well. So this is the medium by which you can, so the term we are using is telecommunication media. Let's go over here, let's look into medium. All right, there's a bunch of medium available. We looked into wireless communication, satellite, wireless. Within wireless we have satellite. So wireless categorize and wireless. Within wireless we have, like 3G, 4G, 5G, Wi-Fi. This is another technology. Within wired we have, of course, over here we use the term twisted pair. This is actually this is traditional telephone line. This could be traditional telephone line. So twisted pair. Another one was Ethernet. The similar idea, very many ways these two are similar, and this is Ethernet. Ethernet is also twisted, so it's not a pair, it's more than a pair. Coaxial cable, this is your coaxial is the cable that you have when you have your dish antenna. This is the dish antenna, your dish antenna communication line, so that is the coaxial cable. So then we have coaxial cable, and then fiber optic cable, of course, fiber optic cable, and terrestrial microwave. So terrestrial microwave, this is microwave, let's put it wireless. So microwave is a wireless. So microwave is, again, if you remember older television channels. So microwave again within, so it is wireless transmission, but like a BTS, often is a higher power. Wireless BTS. Let's do BTS. All right. So cellular, wireless LAN, Wi-Fi. We talked about. So telecommunication processor and software. So processor over here, devices, network devices. So the new term we have over here is telecommunication processor. So switch, bridge, modems. Another one, I don't know if we have, like, let's put in port modem. Modem. So this is one modulator. Multiplexers, again, if you remember, multiple signal are connected together. Router, firewall. Let's put multiplexer over here. Multiplexer. Let's put it like this. So, like, you know, from firewall it goes to a modem. From firewall it goes to a modem, then it goes to a multiplexer. Right? If you remember this data. From a firewall it goes to a router. Let's put in a router. Often they are similar. Often router has built-in firewall. So they work in tandem. And then there is a modem, and then it goes to the internet, your ISP, and then there is of course a multiplexer. Right. So telecommunication device, inter-network processor. So this is different network processing across different network. Hubs we don't use anymore. Because one of the reason is a hub. So if we have a network, small network, let's look into a diagram. So if we have a small network like this, and in between if we have a hub, of course this is not a hub, this is a modem, it shows a modem. But assuming this inter-network, this network processor is a hub, so whenever this one sends a message, it repeats the message to everybody. So what happens is it creates a log, like, you know, there is a lot of data flooding in, compared to if it sends a message, if it can figure out that this message is for this person, for this particular IP, let us be more specific, and then it would be more wonderful, because then this communication lines are not clogged, right? So these are separate. So these are separate lines. These are not one single line. These are separate lines connecting from this. So that's why hub we don't use anymore. Earlier we used hub because hub was cheap. It did not require a lot of processing. But switches are intelligent. Switches, what they can do is they can remember everybody's IP, and next time, first time they create their table, like, you know, routing table, how should they route, right? And then second time on, they can uniquely identify where the message is going, so they will send the message right where it belongs. So that significantly reduces the network traffic. Router, if we have two different networks, then router can communicate. So we have a network over here, and over here we have a local network, and then there is another network which is internet. So like, you know, whenever this it says iPod, let's say it's a smartphone, whenever this smartphone requests some information, or whenever this computer requests some information, it can figure out if they are requesting information from one of these local machines or through the internet. So they will route the message accordingly. All right, so that is one of the nomenclature. So router. Gateways are where your internet exchanges connect, right? Let's see if we have over here. A gateway is where your internet service provider connects to this internet backbone. So your internet provider might have a bunch of network, and then they will pull them together. So if we go over here, so and then they connect to one of the gateway to the internet, by which they route their message. So whenever you are configuring your network, you will often see it will ask for a gateway by which it will go to internet. All right, so we talked about gateway. This is a special type of router, one of the endpoints. So your ISP often provides you with the gateway, with the gateway information. Network operating system. Modern operating systems, Windows, Linux, these are network operating system. But there are certain network operating system that is available for some of this network device. Cisco is one of the operating systems. So Cisco is one of the major major network network device provider. So they have something called the Cisco IOS, right, Internet Network Operating System. So that is one, and of course, like there are other ones. There are Linux based. Often Cisco is also. I think they are also Linux based. Earlier they used another OS. So like mobile phone, Linux based, lot of other dedicated. So for these devices, we have operating system. Often for sophisticated switches, sometimes they call managed, sometimes they are unmanaged. So if you are managed, then you can look into the. Then you need an OS, a good OS that can manage this. We are not going to go too much in detail. If you want to know more, YouTube videos and of course Wikipedia entries are most useful. I use one. It's called DDWRT. So this is free and open source. Then we have telecommunication monitors, right? This this is telecommunication monitor. So we have telecommunication monitor to monitor all incoming and outgoing. So over here we can have a telecommunication monitor and see where these different requests are going. It could be manual. You could manage by yourself, right? Or you can outsource this service. This is part of security. So let's look into security. One more security telecommunication monitor. So this is another device and also security. So this is also network device, and these two are related. So this one is connected. These two we have to connect. So this two is connected, right? So this one and some of the security, and this is connected. But over here, encryption is not a device, but firewall is a device. VPN is a device. Telecommunication monitors are devices. Excuse me. All right. So and network management software, of course, network management software. Some OS has some built-in utilities, we can consider bandwidth, quality of service, how you manage. So there is an OS and there is a bunch of software that can help you manage your network as well. Next step, we have a business systems with very many components. So what do we have, right? We have a payment gateway. We have a third party. Through network we connect to a third party. So what we are having is a let's consider some business use. All right. So third party, within third party we have payment gateway. All right. So we have a payment gateway, and they are connected, of course. Other service providers. So it could be SMS provider, right? SMS provider. Then we have servers. So we are considering business use of network, more specifically network. Business use. So server. So within server we have web servers. Within the server hardware we have web server application. So web servers, they are connected to the network, and then which are in turn connected to web applications, mobile applications. So all of them, web servers, they are connected to, well, like, no, let's put it over here, mobile apps. So they serve through web server. Mobile apps sometimes they serve directly. They can have a separate port. They often do have separate ports, so they serve directly. Then of course web application. So they often connect through web server, web applications. All right, so that's what we have. Different applications we looked into business use. Over here, different API management. So different way the interconnection. The API is interconnection, right? So like, you know, the third party, the connection, third party connected via, it's called API. So API it is like sending message in the background. If you remember, there are certain message whenever you want to buy a pack from your mobile service provider. What you do is write down some kind of code and so on, and automatically system rewards you with certain packages. So similarly, an API is like you are sending a particular message to another server, sending a message to a payment gateway or an SMS provider. Based on your message, they will send message to other people, the SMS provider, or they will accept, or they will take payment on your behalf from your customer. All right, so we have an API management, different ways connection. So through API, you can see all these, everybody is connected, right? And then over here we have, like, you know, through API we also have an analytics, so decision making. So different software. So we are talking about a software, server software, and now we have a decision making. And there were softwares over here as well. So these are also software, right? These are also software. So, like, you know, let's combine them. So well, connections, why black? Who knows? Anyway, so, like, you know, so you can connect. So these are also servers. These are also application. This is also application. Analytics and integration. Like, you know, so over here, integration often through API or some other middle. So how do we connect, right? Software, within software we have for integration. Let's say integration. Of course, integration we do using software, right? Integration software. So this is one form of integration software. So third party payment gateway, this is connecting. Another integration software is middleware. So this software can connect the organization's ERP system to ERP, CRM. So separate system, not e-business suite, which is already connected, and so on and so on. And even functional system, accounting, HRM, and so on. All right. Okay. So we looked into the integration, how integration is going on. And over here you can see a database that is connected as well. And this is another software, ERP software. Over here certain data, CRM software, right, certain data. So we have within software, let's we try to differentiate between software and so let's put all of them. All right, so over here, so what we will we'll look into database, and of course over here networks, database and network. So different type of storage, different types of storage. This decision making, right? So this decision making, and another term for this, and even a higher term for this is analytics, business analytics, analysis, right? Another form of analysis is analytics. So let's do analytics. Google uses this term. So again, this is a analysis service, multiple services, multiple analysis together. So that's why we currently use this term analytics, right? And within the analytics, we have decision making, again business intelligence. How business can make intelligent decision. So this is decision making plus, and database, different types of storage. So business intelligence, BI storage. Let's see BI. And then there is for BI there is large storage. This is called data warehouse. So that houses a lot of data. Okay, so over here we looked into how this network, essentially information system, and we looked into how they are connected. So this we looked into networks, business use or business different use. So this is an information system. We looked at what is part of information system: hardware, software, database, network. Of course, we are talking about network, connecting them, and then people. So except people, this is all the major business use. So network is very important to connect all these. So internal network and external network is very important to connect all this. All right, we are closing in. Over here we can see a sophisticated network. You can consider North-South University might have a network like this, or a medium to large size organization might have a network like this. So what we have, internet. Connecting internet, we have router. We have a router that connects to the internet. Before the router, we have a firewall, and we have a bunch of switch. Before the firewall, we have a bunch of switch. So whenever this person is communicating with, try to communicate with this scanner, so they will go through this, and the switch will say, "Oh, don't go over here. Go through this, and then connect here." Right? So we have a core switch. NSC also has a core switch. The core switch is connected to major services. Over here, IP telephony service. So this is a telephone service. Earlier, if you remember, we said, "Oh, let's have telephone wires for internet." Now we are using internet for telephone, right? And they are connected to other private connection. So this is how IP telephony work. Core switch, there are central storage, so anybody can access. So this direct connection, anybody can access this telephone service. Anywhere there can be a telephone, IP phone, you can see. And also network attached storage. So these network storage servers are available for anybody, and they are connected in their core switches. And other servers. So earlier we talked about web servers. Earlier we talked about different type web servers, mobile app, and web applications, so on. All of these are available through this server. So these servers are available internally, and sometimes if you are hosting your own site, they're also available through this firewall externally, right? So this scanner, can anybody access it from outside? You can have ports ready, IPs blocked, ports blocked. But there are techniques that you can get around with ports and IPs, but for normal use it's not going to happen. So if you remember, VPN was some technique. Hackers always have some technique some or new techniques to hack into the system, and a business always try to find different ways to again manage those, mitigate challenges and so on. So from a core switch we have a bunch of distribution switch, and from this switch we can have secondary switch, or we can have these different devices connected to this switch. If you remember, over here we have a wireless controller. Any switch can have a wireless access control, wireless any of these switch can have a wireless access point. So essentially, like within a switch you can have a separate access point. So this is a router. There, over here you can see. How do I know it's a router? Over here you can see these are the switch. This is the switch, and this is the routing, right? And instead of the switch, we have another wireless switch. That is what we are talking about when we say wireless access point. So we can have wireless access point here. We can have connect it to any of these switches, right? So modern wireless access points are intelligent, so that you can have one wireless access point across North-South University. So there will be one. You don't have to connect and disconnect over and over again. So there are certain technologies that can support this. So from this switch we have IP camera, computer, soft phones. So these IP phones we have now, from software they connect through this, right? So your traditional telephone or VoIP soft phone is possible. So this is a IP phone, right? So they communicate using IP. Network printer, anybody can print within this network. Edge means the last end, right? Edge of a network, edge switches, last end switch. This is the wireless access point, right? And they are connecting. A bunch of wireless people are working wirelessly, IP phone and so on. So this is a moderately detailed diagram, more detailed diagram compared to earlier, of a modern business network. Network topologies. How should you lay out your communication channel and devices? Over here we have a star network, right? Over here we have this is a star network. So you can see this is the star, and from star everybody is connected. And this is a ring network. So it's a ring, and the server is over here, and this is a bus network. So it's a bus, and then it connects. So this is the this we will assume as network driver, right? It is a communication bus. Okay. Now, which one is a good idea? Which one should you use? Now, before you can make a decision, if you remember, the way we make decision is we consider cost and fast and furious and so on, right? So which one is low cost? So if we use a bus network, you can see we can connect from here to here. You can connect from here. We can connect from here. So cost in terms of setting up a new network, new device within the network is not too high. Adding a new network is not high. Compared to this is much higher. So this one is low. This one costs less. This one is higher, because if you want a new device, you have to create a communication line all the way to this central server. And this one is a little bit higher still. Right. This one is a little bit higher. Again, so if you need to communicate, you have to communicate one of these lines. So this one is the cheapest in terms of getting a new device, which is one of the main reason of cost, main component of cost. And then this one is second most, and this one. So in terms of cost, we chose this one. Then we chose this one. Then we chose. How about fast? Which one is the fast one? So if this one, worst case scenario, if this one wants to send a message to this one, over here there is multiple hops, right? Compared to this one is 1, 2. This one is. So this one is the fastest, this one is the second fastest, this one is the slowest, right? And modern networks are moderately fast, so these fast and slowness is not a major concern. But consider this, what is the last one we should consider? Another consideration is reliability. Which one is reliable? which one is reliable. So in a star network, if the star goes down, that is the worst case scenario, and the network goes down, right? So again, like if just one central one goes down, then if the network goes down, then that is a challenge. Compared to in a ring network, often if there is a break, if the connection breaks over here, the network works, because even this one over here we had a break, even this one can connect all the way over here. If if two connection breaks, then maybe you have a disconnect. So much more reliable ring network. So this topology is sometimes used by your network cable provider, where networks are breaking over and over again, and they want to ensure that network will not break. This is costly. This requires much more network communication medium, right? So much more wire. But and bus network, again, the speed is a little bit slow. So if we don't use the ring network, often a bus network is used for your typical ISP, traditional ISP. And not just one, multiple networks. So they might have a ring network and then they will go a bus, right? Star network are seldom used. Star network is used at the top end, if you will. But more specifically, a ring network and then a bus, ring and bus. So multiple network topology is used by modern businesses. So over here, what do we see? We see bus. We see bus over and over again. We have a star. We have a star, then we have a bus, right? So over here, this is the star code switch. Everybody connects to this. This one shuts down. Everything is going to be down. So so reliability is a little bit low, but it is simple, right? Easily manageable. So we looked into network topologies. Again, every time you look into any of these topics, consider what it is, advantage, disadvantage. So which one should you choose? That could be a question. All right, network topology we looked into. Over here we have another diagram. So how it goes. So network topology, how it goes. So one host to another host, how it goes. That is the topology. Now, within network topology, how data flows, right? So we are looking into a diagram of a data flow. So one communication to another communication data flows. We looked into this data flow earlier, right? Over here we looked into the data flow at a high level. This time along, what we are going to go is we are going to do a detailed data flow. Before we do that, let's look into network topology. So we looked into network topology, then said star, bus, ring, and we liked ring, but ring was a little bit expensive still. Then we looked into, what else did we look into? All right, so this was just a simple example. All right, this time we will look into data flow. All right, so this time we'll look into data flow. All right, so how data flows. So you can see over here, from here, how data flows to here, right? So any two device, any two device. So we have host. So application. For data to flow, both applications, let's say both of them are using WhatsApp, right? So WhatsApp, this WhatsApp to this WhatsApp, there need to be a connection, but they cannot directly connect. They have to go through their OS and then through their network, right? So what happens is at a transport layer, there is a layer, right? So for data flow, there are multiple layers. Over here, you can see we have 1, 2, 3, 4, 5, 6, 7 different layers, right? So OSI layer. So how can we communicate? So there is something called OSI layer. So this layer is to make sure this is a standard. So make sure everybody understands how to communicate. What is the role? So this is a standard. This clearly defines role. Roles for what? OS, network device, application, right? Network device including network interface card. Sometimes use the term NIC. Okay, so we have a so what we have again, software to software we have a communication, then host to host, so this machine to this machine, then it goes to internet through different link. So this is the network. So host to host, for the most part at this transport layer we are talking about OS to OS, and then it goes through network card and so on. So it can go through, like, from your network, it can go through another network, and then ultimately. So, like, over here we have said, oh, it can go through very many network, and over here as well we said, oh, it can go through very many networks, right? And then once it goes through these different networks, then it again comes to through a Ethernet. If you remember Ethernet cable, it comes to their computer. So this internet link, we'll look into detail in a little bit. So this internet link allows the data to flow, right? Simple network topology to host to host. So over here we see this same diagram in detail. This diagram looks a little bit complex. So what we have done is we have created 1, 2, 3, 4 diagrams. We will explain the same thing. All right. The book has 1 diagram, but we have 4. So within this application layer, you can split this application layer into 3 layers: application, presentation, right, and session. So application layer is where end user interacts. Presentation layer is where the certain data need to be encrypted, decrypted if needed, right? And session layer is synchronization. So session layer is like, I am using this browser, and then I'm going to different sites, right? So there are different sessions. So this browser has these 3 different layers, right? And over here it does not say this 3. It does not separate. It says it keeps it simple. It says, oh, there is just an application layer. After session layer, we have a transport layer. So over here, however data the session layer will give me, the session will not give me, but the session layer gives to the host or the OS. What it does is it creates message, like, so a large data, let's say video, that is you are sending through your WhatsApp, they segment, they make it pieces, right? And then they make this transfer. They made these pieces, and then from these individual pieces according to network size, right? And then this is the transport layer, and then the network layer, from these pieces they create packets. The packet will have IP address, like who's sending, who's receiving. A little bit more detail is available over here. We are of course looking into high level data. We are looking into from a high level. Much detail is often relevant to network engineers. We as business users, we are trying to figure out what is going on with my data. So we know that from our application, it is sent to the host OS, and which then segments. Then it goes to the network layer where the packets are built, and from the packets, these packets are sent to your data link on their network interface card, right? So this network interface card, these packets are sent to your network interface cards, and once it is sent to your network interface cards, it creates different type of, so this creates frames. From these packets, it creates again, it modifies, creates a new different from a new type of packet. These frames, you can consider them as a new type of packet. So over here it says now the packet is made, so they make sure this new frame has, if there is an error, how should it receive a reply, and so on. So this creates a communication with your router. Let's say if it's your desktop computer, it connects to your router, right? So data link layer. So this is the network interface card. It could be wireless network interface card. Same ideas, right? So then it goes to the physical layer. This is the real digital data, 0 and 1, and these can connect to other. This connect through cables to other networking devices. This is a little bit small. If you want to read, sometime you can maybe zoom a little bit, right? Then we can have over here, it says, we can have data encoding in different levels. Earlier we talked about VPN. So this happens. So when we are doing VPN, the software creates multiple packets. All right. Let's look into this one from one more angle. So there are multiple layers. So there are different models. OSI model, TCP/IP protocol architecture. So OSI model says application layer, presentation layer, session layer. So 7 layers: transport layer, network layer, data link layer. Again, why do we do these layers? Clearly define the role of OS, network, device, application, and so on. Then, same model, when we look into TCP/IP model, the same model is divided into application layer. This tree is an application layer, right? So this makes it a little bit simpler, but this gives more detail. Then host to host transport layer, right? So this is called transport layer, host to host transport layer. So again, over here, this one gives you different protocol. So HTTP, FTP. So that is happening in the application layer. So the HTTP, FTP, other different protocols, SNMP and HTTPS, FTP. This protocol is happening at this layer. And host to host communication. So host to host. So over here, host to host, or over here, any host to host. This host to this host, or this host to this IP camera. So IP camera also knows this. There is a protocol for IP camera as well. So we can communicate using, if you remember, we made this over here. We made this message segmentation. Both of them, we are trying to make packets, right? So host to host, we are making TCP and UDP packets. TCP is for reliable communication. UDP is often for broadcast. So when I am sending video, I don't care if 1 or 2 of the packets are lost. But TCP ensures that every packet, so there is checking. How do we check? If you remember, everywhere we were adding data, extra data, right? So IP data, again packet check data, these are available. So from this, it goes to network or internet layer. So again, we are packaging, we are putting in IP, and those data, adding IP and creating this packet. Now this packet is available for our network. Network layer, over here OSI has defined 2, data link layer and physical layer. Over here TCP/IP says, both of them are single layer. So this is the activity of network interface cards. Physical layer, over here OSI model, you can distinguish physical layer as your signal, actual signal that is sent out. It could be electrical signal, RF, radio frequency signal, or if it's a fiber optic, it's a laser signal. Compared to this network interface layer or data link layer, so again this is your network interface card or Wi-Fi card. So network interface card, Wi-Fi card. Again 5G card, you can consider that as well. 5G is not, of course, not commonly available through your computer, but through your smartphone. Again, same ideas apply. So same OS, same process are available. So again, over here you can see there are multiple protocols. Ethernet is one protocol. PPP is another protocol. Frame relay is another protocol. And interface driver, how to use. So again, interface driver is the device driver to connect. If you remember from the last chapter, we looked into drivers. So again, the OS knows through a driver how to send these different data. So again, over here, this is data, this is data, this is data. This is called segment, TCP UDP segment. This is called packet, right, at this level. and after packet this is called frame, and these are the bits. I hope this one clarifies some of these ideas. So again, TCP model, so the two models. So this one is not very relevant. Let's the same model. This is from your book, so this one is not as informative the way we looked into. Anyway, if you need further information, of course, you can talk to me during an office hour. So that closes today's section. Thank you for staying as long.